Hello, hello. Welcome everyone to our session today. Let's get things rolling. Oh. To our Hour of AI for Alaska live learning event. We're going to be getting going here, looking through all of our Hour of AI content. If you're following along in the classroom, let us know, say hi. Otherwise, if you're following along on your own, excited to have you. My name is Sean Marshke. I'm a professional development here at Tinker and CodeHS. Got about 16 years of technology education, including 6 years working with CS and CTE teachers like yourselves. Excited to get into some AI today. To get things rolling, we're going to look at all of the Hour of I activities we have in Tinker. They're all going to be based off of the pose detection that's been taught through some machine learning. You'll find all of that at tinker.com/hour of AI. Thank you, Steve, for sharing that. You'll find when you come to this page, all five Hour of AIs we have available. You'll see Weather Control, Balancing Act, Tickle Monster, and Turtle Racer are all flagged as beginner. They'll be using the basic Tinker block coding. Anyone who's ambitious or you're working with maybe some high school level students, you're familiar with JavaScript though, feel free to check out the Fruit Fighter that goes into some JavaScript coding to actually do some triggering, which would be a pretty fun one. Today we're going to be going into Turtle Racer, but all of these are going to be using different gesture recognition with CodeHS or with the Tinker AI. So you'll be able to use webcams, and these AI models have been trained on the different gesture recognition. So it's super fun to kind of get to play around with different interactive elements there. For all of these, you'll have the links down the bottom here for events. For yourselves as teachers, you can check out the teacher guides for any one of these with the links down below here. And you'll have a nice little PDF giving you high-level outlines, a little welcome, and how to prepare yourselves. Um, your students can have Tinker accounts, or you can come to this page without being logged in, though, and being able to work through them. Just note, if they do want to save, or if you want to save anything, you do have to be logged into Tinker to be able to do that. So definitely take a look at all of that. So we just went through everything that's included. Every single one of these, just to kind of point out, you can click into and check out right now, and it'll give you a little preview at the start of each one as well of what you can expect to be doing. So with the balancing act, for example, it's going to be using our camera with our head to try and balance a ball on top of it there and keep it up, as long as you can. So students will get to build this, but you can kind of play around with any of those and check it out. But let's hop back here. Yeah, and you can find any of those again at the tinker.com/hour of AI. But to get things rolling here, we're going to do a little education on how training AI models works. We're going to look at a couple different free available through Google AI little games that explain how these AI models are trained. So the three that are available are Teachable Machine, which trains either through sound clips or images, as you can kind of see in the little thumbnail there, how to recognize different things that you get to train up your own little model with those, which is really fun. Great example to kind of do as a whole class. We have activities actually using this to use recognize music genres as well, which is really cool. The XYZ toy actually shows you what an AI thinks different letters or words represent. So this one's fun to kind of reverse engineer how an AI model is trained. But the one we're going to play with today is Quick Draw, which I have open here. Steve shared the links for all three of these, though, if you definitely want to take a look at those later on. But Quick Draw basically is built from a neural network that's been basically submitted thousands and thousands, if not millions, of drawings of different things, and that's how it's learned, right? And so we can see, based off of my probably terrible drawing, if we can actually get it to recognize these things, right? So picture frame in under 20 seconds. Okay, so let's do a quick drawing.
I see line. I see square, or suitcase, or tooth. I see dishwasher. Oh, I know. It's picture frame.
There we go. Oh boy, tiger in 20 seconds. Let's see. We're gonna
I
do
see
our
knee, or
face,
fork, or necklace, or moon, or circle. I see apple, or
ears
blueberry, or bracelet, or bear. I see panda.
with cat nose. I have 8
I'm not
seconds.
sure what that is.
Stripes.
I have no clue what you're drawing. Oh, I know. It's
Okay.
tiger.
It really starts to shake your confidence in bad drawings, but it figured it out. Amazing. I did not read book. Okay, so
I
clicking
see
and
line.
typing.
I see leg, or broom, or square, or door, or cup. Oh, I know. It's book.
Nice book. So we're just going to go through and get our drawings here.
I
Mouse.
see line. I see
Oh,
green
that's way too
bean, or
small.
paperclip, or bread, or bandage. I see drill, or shoe, or marker, or screwdriver, or finger. I see seesaw. I see clarinet, or pencil, or
Clarinet.
crayon. I see springboard. Oh, I know. It's mouse.
Okay, we got there. Uh, oh, I've never seen this one. Oh my God. Camo.
I
Let's
see line, or suitcase, or
do
square, or
gloves.
dishwasher, or postcard. I see map, or drill. Oh, I know. It's
Okay.
camouflage.
We figured it out, team. And last one, some shorts. This we got. So
I see line, or leg, or elbow. Oh, I know. It's shorts.
shorts, easy. All right. So, anyways, uh, you can go through, you do these little drawings. Hopefully, you get it to figure out. I've done this enough that I generally can get 6 out of 6, but every once in a while, it'll throw me for a loop. And what you can see here is how your drawings, match up, but you can actually click into any one of these drawings that are out here. It'll show you how the neural network recognized it, other drawings that it's seen that maybe match. So like square is one, oven is one, and how it was like trying to figure out what those different things were. And then you'll also see like what other people have drawn. So this is what this model has been trained on, right? And so you can kind of example and see that and demonstrate to your students. But you also have here data. And this is really cool because it allows you to see all 50 million drawings that have been made for a bunch of different folks out here on the internet that have actually trained up these things, right? And you can kind of show how, okay, this is a bottle cap. If I click on it, this is a bottle cap. These are all the bottle caps that people have drawn and how it's learned over time all the different ways we can interpret a bottle cap. So we'll give everyone maybe a moment or two. You can try out one of these games with your class if you're doing it. If you have any questions on AI or how it works, I'll be happy to address those. But yeah, we'll say let's have like a 2 or 3 minutes. If you want to open up the link, try it out yourself with the quick draw, or you can play with the XYZ toy link. Teachable machine takes a little more time to set up, so probably don't want to mess around with too much with that. But I think quick draw is a great example here of how machines learn, right? How we train these models to actually understand what it means when we give it any sort of phrase out there, right? And then this in turn is how many of the like images and other drawing AI robots are out there, right? In the meantime, I'll click through some other random drawings. So we got broccoli. Yeah, right, Anthony. Yeah, you can see here most of these are either bad mouse drawings or trackpad drawings, so it's pretty fun how it can learn. That's also though sometimes why it gets like funny in the guesses it makes, right? So I wonder if we can find actually if we go back, like what are some of these other camouflages people have done? Yeah, see, camouflage is such a weird one. So it figuring out like a lot of people do this shirt sort of thing, but the blobs is maybe like what helps trigger it. Some very abstract art. Awesome. Some great input there. If you ever want, you have the this codehs.com/AI resources. You can save this whole link if you want to always have access to all three of those and find them anytime. You can always come back and try them out some more as well. But with that said, we're going to hop into our Tinker game now to help everyone learn a little bit about these AI models that I referenced before. So you're going to go into Turtle Racer, as you saw in the little screen cap here. You're going to go to that Tinker Hour of AI. AI. We got Turtle Racer here. You do always have that teacher guide for it, so you can always come back and reference that if you're going to run it on your own with any other classes. Again, that link was down at the bottom here under teacher notes. But when you're ready to launch it, you can just click here. As I mentioned before, without having a Tinker account, you can come in here and start this lesson. You'll be able to go through, set it up, program everything. Just note if you do want to save it, you'll need to log in with an account, and then you'll be able to use this save button to actually save your project. So Total Racer, really, really fun. Again, it's going to use gestures in tracking your hands to actually steer our little turtle friend here around to collect his kelp. So we'll see here when I raise my hands, it's actually tracking where they're at. To make it more realistic, you can go in your little driving gesture and it'll steer a little turtle friend over to, let's grab some kelp. Okay, got one. Okay, and you just go around and eat all the kelp. And when you get to the end of it, you win, right? And so we're going to program this game, do the basics here, learn how we tell our program to actually look for these gestures, and then build out the rest of the programming for actually steering our turtle based off of that and programming everything from there. So we're going to see how to enable and show that hand detection and then use that angle to like landmark how we want to go through. And so to start, you're going to actually turn on hands detection. So there's actually a block out here in any of our programs with the AI features enabled where we can start hands detection. There's also face and body detection. You'll see in some of the other hours of AI. And we want to be able to see that detection on our screen so we can kind of correct. So we're going to have that show detection block. And so we'll see just by doing this, when I try my code with the stage set to on start, show start and show the detection, I now can wave and keep track of that. What's neat is it actually keeps track of which hand is which based off of the training it's received, even if you're facing front or back. So really, really cool. You can do all the appropriate, school appropriate gestures here and stop from that. And so when we were ready to move on, we can use our next button to progress through the tutorial. All these tutorials, by the way, you can at any time hop out and add more by hitting this close tutorial box, and you'll see all the options, all the coding options you have available. And you can turn it back on by hitting show tutorial. So we're going to actually add our code now to our turtle. So you can see here it's hopped to the turtle. It's highlighted over on the right here as well. And program how the turtle is going to work once we start our program. So the on start block here, right? And so we're setting our rotation style, which means it can actually rotate, in this case, all around. It can spin full 360 degrees. And we're going to set its start direction as 0, which is straight up. And then we're creating a forever loop with this. So forever loops, if you don't know, that's in our block coding here telling it as long as this game is running, we need to be doing something here. And so we're going to program that part of it in a second. But we first need to just add in here code for keeping our turtle in bounds. So when you're coding a game, what you see on the canvas here is not the only place in the world, right, that you're creating. Things can actually come on and off of this screen, this little canvas. And so if we want to keep something kept within it, we set up something like this get bounds here that is a variable we've programmed that is constantly checking the position of our turtle. And then when we add the variable to get bounds into our forever loop here, it will constantly be checking this code to make sure our turtle's in the right position. And as well, we're also going to be telling it to just constantly be moving forward 1 pixel at a time. And so we put that in, and we should have something that looks like this with our on start block. And so this is our basic behavior for our turtle. It can rotate. It always points, it starts off. We notice here it's not always pointing at 0 degrees, but at the very start, it will point at 0 degrees. It's checking if it's in bounds, and it's moving 1 pixel at a time, right? So we've now coded our turtle to keep track of these things. After that, we now need to actually be able to pilot our turtle. So this is the fun of it, right? We actually get to tell the turtle where to go. And so we need to actually program it because as of right now, when I play, he's just going straight. Like while I can wave at him, we haven't actually tied the turtle to, let me blow it up here so you can see, we haven't actually tied that steering in yet. So all we have is the straightforward moving that we have set at the 0 degrees, right? One at a time. So inside our forever loop, we're going to set an angle. So we'll do set angle. It's going to be looking at our left and right wrist. And we program the angle based off of if the angle is one set of degrees or another, it'll start turning in one direction, one way or the other. So we can see here, it's checking the angle. Our angle is programmed as left versus right wrist. It's looking at, if you know your geometry, a circle is 360 degrees. We can rotate anywhere in that direction, but it's just checking if one direction is more than 180, it's going to turn left. And if it's less than 180 degrees, with our if statement here, it's going to be turning right. And that makes sense because we're comparing left wrist versus right wrist, right? So now, with all that in here, we should be able to steer our turtle. So I have my one hand, I have my other hand, and now based off of the point in my wrist, it'll actually give it a different direction, left versus right. And just because you have programmed the turtle doesn't necessarily mean you're the best steerer of the turtle. But you can see here, I was able to get all the kelp, but at this point, we haven't actually defined how you win the game. And so that'll be our next step here. And that's to keep score, right? So we're back in the stage because that's like kind of the core where we're actually keeping track of everything. So we need to actually program it so where it eats all the kelp, we will actually win the game. So we're going to set our default score to 0. I'm going to plug that in here as the very start thing, the very first thing it does on start, though it does pretty much all these right at the same time. And then we need to say once we've eaten all four of our kelps, we've won. So this nice block here basically does that, where it's checking if the score is equal to 4. We'll get a little message that says we win, and a little message at the bottom, and has some fonts laid out there. And we can see here our blocks look just like that, our on start block. And finally, we need to actually tie scoring into our kelp. For each one that gets eaten, it actually changes the score. So it'll tell us here in the kelp actor, on the block below the if touching turtle box, we need under the clone startup to change the score. So if it's touched the turtle, we need it to change our score. And it'll actually move the kelp off then too. And so the idea with this is it's going to clone itself a certain number of times. So it's doing it 4 times. And then for each of the clones, forever, it's going to check if the turtles caught it, change our score, and then teleport off the screen, basically, making it disappear, right? And so we'll see our code looks right. And we could try it out, right? So in theory, we've done everything we need to. We can try our code, see our hands, and try and steer and get all our kelp. Oh my gosh. So going up and catching kelp. Oh God. And we win, right? Just like that. So we get a little message there. We win. Pretty cool, right? So uh, if you're following along, if you're trying to catch up, feel free to take a few minutes, go through, get your code in here for all the steps to actually get the base game set up. If anyone has any trouble or questions as you go through, we'll wait here a few minutes. And then we'll talk a little bit about extensions you can do with this as well, that will leave you to actually go off and try out. But we'll give everyone like 3 or 4 minutes to get caught up here. Let us know if you have questions as you're going through. I'd be happy to talk through those. Awesome. Let me adjust myself in the preview here. So if anyone had any trouble, definitely let me know. Be happy to answer questions, but we're gonna hop forward here, talk through once you like get through this basic coding, like it's a game, right? So you can actually increase levels, add more difficulty. It's pretty fun stuff. If you go next here, it'll give you some recommendations where you could increase the speed of the turtle by the number of pixels it moves by, which, if you recall, in our turtle code here on start, forever, it's moving 1 pixel. So if that speed that it was going at was not challenging enough for you, we could try and double it by going 2 pixels a second. If we play here, we have Hyper Turtle, and I am just never going to actually be able to beat this level, but my oh, maybe I can get there. But anyways, hey, okay. So obviously that's a very simple tweak you could do, but like increase the difficulty obviously by tweaking that speed. And so remember that's under our forever loop. You can adjust the move speed by the number of pixels it's going per second. Um, you can tweak how much it's actually like turning, though that's a little trickier for the angle. It'll actually make a wider turn based off of the number of pixels you're doing. You can also change the amount of kelp you have to eat that's generated, which we can do under the kelp actor here, as you can see. And so if I want more kelps, uh, we have the clone information here, but the on start is where it actually does the cloning of the uh, actual kelp that it's creating. And so we tell it how many times we want to create a clone of kelp, and then it'll actually pull a index for where it's going to actually drop it off at. Excuse me. And so, yeah, oh, that's a good call. So that's like another thing we could do is actually add levels to this, which we can talk through in a second here as well. To have it create more kelps, you can tell it to repeat here a certain number of times. So say I want to collect 6 kelps instead of 8 or 4. I adjust this repeat here, and next time I run, I have 6 of them out here, and I can start steering and trying to catch all those. So if you noticed, I caught 2 kind of right at the beginning there. Okay. But notice I didn't actually eat them all, but it's already telling me I want. So if you recall, uh, in addition, when we were setting our score, it wasn't just adjusting the kelp to increase the score each time, but we also on back on that stage set what the winning score is, right? So if we want to change the score to win to be 6 to match the total number of kelps we're going to have out there, we have to update this number then as well, right? And so that's keeping track of those different variables. So now I would have to eat all 6 kelps to actually get in there. Uh, to Anthony's point, you could actually add levels. You do that in the upper right here. You can add a level. I can have it go back and change here up at the top. Uh, and actually, what's probably an easier thing to do than adding it blank is from this level screen now that I see at the top here, I can actually copy this level with this little plus button, and it will actually copy level 1 based off of the exact same code, but I can then tweak different things, right? So it's pretty fun. I can edit the name of this to be level 2, maybe 2. By clicking in the name, I can copy level 2, be level 3. And each of these levels I can go into and make little changes like we talked about. Yeah, so we can now make the speed 3 for level 2. and then the speed 4 for level 3. Add more kelps to collect. And then you could even start doing things like adding enemies with extra actors. So I can come in here, add an actor. You can go and find in the media library, or you can build your own character, or even just draw something for yourself. But under like media library here, I can find, hey, right here, I got a shark with some code built into it already, which makes it nice and easy for me. I can say the default stuff here, okay, it moves by default towards, yeah, and plastic straws is good too. Uh, so by default, it's going to point towards my mouse pointer is the code that's built into this shark. But I could say, okay, just always head to the right edge. I just want it to maybe run parallel across. So I can choose run towards right edge. Uh, or I could just say point towards edge, and it will move back and forth based off of where it goes on the edge. So now if I run, I can kind of test that out. So we got our little shark kind of chomping around, and he can bounce off the edge. He chomps when he runs into things, pretty fun. Um, and then you would just have to add code here for like when if our turtle touches the shark, we would have to add maybe some code here to say if touching shark, lose a point or lose a life. And